Next, Mr. Yang. Mr. Yang will show us around to unveil the secrets of technologies inside the smart 3D car park. What's the overall situation? Hello, audiences. Our project is located beside the zoo in Jiulongpo district of Chongqing City. We have a huge number of cars commuting in this area. As we all know, we have narrow spaces in Chongqing City. Therefore, parking is an issue for people right here. We have constructed a 3D car park. From the exterior, it is like an office building. But on the inside, there are no personnel, only cars. We have a glass exterior. How many stories are there? And how many car parks are there? We have 20 stories. We have 20 stories above the ground and 2 stories below the ground, and in total we have 387 positions for a car park. Traditionally, one car's parking space takes about 10 square meters. So in total, it would require 3,870 square meters for 387 cars. But we only have an area of 680 square meters. At the same time, we also save energies in this building, because on average, parking in one position only takes 0.2 degree of electricity, and our customers can scan the QR code, and then the cars will be automatically moved upwards. So we have saved energies and we have cut emissions. This also conforms to the green development, and it is also very convenient to extract your cars. You can also scan a QR code. Normally, people sometimes would forget where they park their cars, but now this won't be an issue. We can see a car just entered. After scanning the QR code, the car owner can leave. And then when you are taking your cars away, you can also scan the QR code at that side. And this process takes about 90 seconds. And our technology is first class in the country. And we're also using this by driving this inside with the head of the car inside. And when we are taking our cars away, the head of the car will be facing outward. So drivers do not need to back up. Mr. Yang has introduced a lot of interesting details about this, and now we're going to experience it. We have pre-arranged one car to be parked here, and we'll show you the process. And this car is also going inside. Let's come nearer. Mr. Yang, in the process of cars running, how can we judge if there are spaces inside? First, empty spaces would suggest a closed gate, and then you can drive your car slowly inside it. And we have a sensing facility buried underground, and the gate would open automatically, and the cars can be parked inside slowly. And Voice directions are also provided. After parking your car and taking up the handbrake, you need to scan the QR code by your mobile phone. And then the cars would be parked upward automatically. As you can see, there are two infrared lines. This is an automatic judging software to judge it from an SUV to a sedan. If it is a SUV, it would be parked under the 7th floor, and if it's a sedan, we would park it in the 7th to 19th floor. So after scanning the QR code, you can just leave? Yes. So this is very convenient because it does not require car owners to drive inside a parking lot and find a spot. This is the first ever smart 3D car park in Chongqing City. Now we have already parked, so when we are taking our cars away, I can still scan the QR code by my mobile phones. Yes, there are two ways to take your cars away. The first one is to scan the QR code. Another approach is we have a self-payment machine. As we can see, the car has vanished. If it were me, I would be worried what happened to my car. But later, I will show you the inside of this building because we have a monitor system. This is a smart self-payment machine. Why did we make this? In case some car owners' phones have died, so they can enter their car plates and take their cars away. Now we're taking a look at the control room. Okay, let's come over here. It was like magic and my car just vanished. I would be worried what happened to my car. This is our control room. This is like the brain of the car park. There are four parts, and 3 of them are square and 1 of them is round. In total, they can park up to 387 cars. For the square parts, by the monitoring, we can see that on the 2 sides, there can be parked 3 cars. So in total, it's 6. And for the round part, we can park 5 cars inside of them. This orange facility is the lifting equipment, just as the lifts that we're using daily. After driving the cars into the belt, we have a lifting equipment and lifting it by the small lift and then put it into the specific position. Some car owners would feel dangerous or some other things, but rest assured, because we have a very mature technology right now. Globally, we have a lot of patents, and the security is guaranteed. Even if the steel broke, the platform would not fall off because we have a brake that can stop from falling. As we can see, there is a blue car entering the car park, and we can see it from the inside. Now the car owner is stepping out. I have another question. Why do we have to take the handbrake? If we do not take up the handbrake, it would not be delivered inside the car park because the car is heavy by itself. So when the conveyor belt is moving, the car will also be moving. Now let's take a look at the blue car. Is this platform taking it? There are a lot of car park positions, and we can see it in later videos. This is convoyed by computer. There are no people inside of this car park, so I would like to remind you to step out for every passenger before real parking. And you need to take your belongings with you, and then the cars will be parked upward, and no personnel is allowed inside the car park. This is calculated automatically by the computers. As we said about the infrared thing, we have a system in the lift. If your car is blocking the infrared thing, it would stop. And now this has stopped. So manually, it is very convenient for us. We do not need to find spots anymore, and we do not need to find our cars anymore, and this saves the time of the car owners. Also, the energy. Also, it cut the emissions. I still have one more concern. Would the cars be scratched in the process? You do not need to worry about that. I just want to remind the car owners, when driving inside of the entrance, we have a mirror inside the gate. This is not for looking into the mirror to look on ourselves, but for us to put the car in the middle position in the entrance. Maybe some car drivers are nervous about their first times in parking in this car park, but this is actually very simple. According to the monitor, we can see that this is totally manless operation. If there's any problems occurring, we can manually operate. For example, one car is having problem with its car plate. We can use this operation box to take it down manually. If I do not have a car plate, what would the car park do? We have staff here that will help the cars without car plates. What kind of operation boxes are there? What's the meaning of them? For these boxes, one of them can operate the whole of one part of the parking. You can see there are several car plates inside of them. Every car plate number is remembered by this. And our personnel can manage the cars by looking at them. If we need human interference, they can operate on this, right? Yes. We can manage the statistics according to these. Can you demonstrate us to use this? For example, if you're looking for a car or switching a place. Okay, there's no problem. We have a staff. If I want to take one car away, how do we operate? Which car are you taking away? You need to remember the plate. Which part did you park? The silver one that we just parked in. It was in the A part, and now we're looking for the car plate number. If there is malfunctioning in the automatic system, I could look for the information right here, right? Yes. Now we're looking for the silver car. Which is the car plate number, is it? Do we need to input, or do we just look for it? The car that we just parked in is this one. If we need to take it down manually, we can do it right here. We can input the number, 7th floor, spot 1. And now you can see which is a vacant position, and we'll take it there. The car will be found automatically. Now it has found the car. If the car owner told us the car plate number, we can find it here and operate automatically. Just now, Mr. Yang told us that the head of the car would be switched to the outside. But this car we're seeing right now is not switched around, because when we are parking this car, the head of the car is not switched. And we were parking outside. When we're parking inside, the head of the car is facing outward. So if you're seeing from the interior, you can only see the butts of the cars. So in the process of what you see, the head of the car is already facing outward. If you're extracting it from another side, it will be switched. We will see the switching part later. It's the process of rotating inside the racing portion. Yes, it saves time, but also it has something to do with the floors. The rotation and the lifting goes together. This high-tech experience is really awesome. Let's take a look at the round part of the parking lot. Currently, another journalist with us is inside this 3D car park, and we'll bring you a closer look. And please connect to another journalist, Wang Lei.
就刚才杨老师说的，它其实在这个取车的过程中，它就会有一个自动的旋
This
转。
looks very amazing, this 3D car park. As Mr. Yang said, we have an automatic rotation when taking cars away. Dear audiences, hello. My colleague Deng Lijuan has showed you outside the car park, and we have seen the 3D car park from the exterior and how the cars are parked. This is very amazing. So in a few seconds, when the gate reopened again after we put our cars in, the car has vanished. And now for a more direct feeling, now I am at the top floor at the car park. Now we have a good view because we're at the top floor. This is rather high. And now we can see the whole structure of the 3D car park. Now I will show you. This is the structure. Now a car has been transported to this floor. And how is this parked? I'll introduce to you right now. A technician of our car park, Chongqing. He is our guest today. So normally for our audiences who are car owners, they cannot enter a building like this. So let's see more directly about how these cars are parked. Now we're at the inside of the 3D car park. One floor of this has 5 parking spots. And now this car has been parked to the third car park. We used convoys and robotic arms to finish this putting. If we want to move this car into another floor, can this be done? The car spots are automatically divided and distributed because of the height of the cars. So as long as we have car spots, it will be parked automatically. So the top floor can be parked with sedans and small cars. So the second to the 6th floor can park SUV and higher vehicles. And from the 7th to the 19th floor, smaller cars such as sedans are parked. So we have different floors for different kinds of vehicles. Now we'll bring you closer with the experience. So we can see how the lift is operated. Now we are walking inside a car spot. So this can be put together with the lift, where cars are convoyed up. Now, please, I'll show you. After being raised to this floor, the cars will be automatically convoyed to this belt. So how this is really operated, he can show us. This white car right here was raised up here and then park here. But this floor has 5 spots. If I can park into this spot, it can be realized as well. Our colleague in the control room can help us to move the car to the 5th spot. We need to wait for a moment. It can not only be moved horizontally, but we can also move it to a lower floor. The robotic arm has already reached over. The principle is like conveyor belt. Now the robotic arm is going to put away, and now rotation. After the rotation, what is the principle to move it to this spot? We have gears inside the lift and the car spot, and they can connect together. So the gears are actually bringing the car over. It's the belt that's moving the car, and the wheels of the car are not moving. And now this car is being parked in the 5th spot. And can it differentiate spots with empty ones and full ones? The machine have a memory of parking cars. If this car has been parked to the 5th spot, and then it will automatically remember. This is a sensing facility. If one car has entered, the memory will serve as being one car parked. So judging the car park is empty or not is a necessity for us. And we have 2 sides information, serving as 2 layers for protection. So in my understanding, the 2 layers of protection, there won't be any occasions where cars are bumping into each other. Because we have 2 layers of protection. For example, sometimes we can be worried about the malfunctioning of machines where 2 cars are being parked into the same place. We have an emergency and contingency plan and normal standards, which both guarantee there will not be 2 cars parking into the same space. Now we are walking on one car spot, and we'll take a look on the lift. Rotate the lift into the 4th spot. Yesterday we came here to communicate with them. So first, we guarantee the safety of ours, and we're bringing you to see how this works. But in normal situations, car owners are not allowed to come inside this building, and they do not need to come inside. So from here, we can see the height because we're at the top floor. You can see that every floor has 5 spots and every floor can be parked. So in total, 387 cars can be parked in here. Now we are in the D car park, around one. So in A, B, and C car park, they are square. Now we are at the lifting platform. Normally, this would convey each car to the floors where they will be parked. It can be moved upward and downward as well as rotate. Let's see how it is rotated and moved upward and downward. My question is that if there are a lot of vehicles, can this be moved quickly enough? So after calculation, we have divided cars into different car parks in order to move the efficiency even further. Now we are in the D car park, and for the A, B, C car parks, all of them can take about 100 cars. So by rotation, this lift can deliver different cars into different car spots. And now you can see the rotation, and we have a gear. The gears will connect together, and the conveyor belt will be moving cars into the exact car spot. So the power comes all from the lift, which I'm standing on. So the cars will be very secure. It will be parked right here. There are no powers at all, so there are no dangers. This is very safe and scientific. But still, I have one question for Mr. Cheng. In the designing process, for example, these 5 car spots are static, but why did we not design it for the moving pattern for these 5 spots? Will it accelerate this process even faster? You mean by moving these car spots to make it more intelligent and 3D? If that is the case, we need to add more equipment and facility to the car parks. So from construction and cost perspective, that is a whole other story. That will become too much complicated. As you can see, this is hollow, this part. We can actually put in car spots, but we have a unified designing because on that side it is the square car parks, and now we're at the round car park. So this whole building can be used for parking, right? And now we are very safe, and please, our cameraman can stand on this platform as well. And now we'll take you to experience the process of going upward and downward. So as long as Mr. Chongqing gives an order, this platform can be taken down. This process is really quick. You can see the speed of ours. because this is only a demonstration. So Mr. Chongqing is giving order to the control room. But in daily times, there are no staff. This is so much faster than our normal lift. And because of this speed, the cars can be parked exactly and precisely. Because there are not a lot of cars right now, if there are more cars, we need this speed for precision and time saving. You can take a look upward. I think this is a good view. The car spots are very neat. If the car parks are full, we can see their heads. Now we are at the 10th floor. There are different zones for cars. If there are bigger cars, such as SUV, we can only park them in lower floors. There are basically two kinds. One kind is SUV, and the second is sedan. And in recent years, they are adding numbers of SUVs. And in our consideration in the designing process, we have put SUVs into the 2nd to the 6th floor. Okay, even though this is a smart car park, maybe we can come onto the car spot. Can we move the car from the top floor to this floor? Yes, let's take a step outside here, because this lift is going to take the car up there and take it down here. Let's move on to this platform. The height of the floor is lower than the one that we had on the top floor. Now we are at the 10th floor. This is not even 2 meters, because sedans are mostly 1.55 meters. This is for sedans. I thought you said the lower parts will be parked with sedans. No, the 2nd to the 6th floor will be parked with the SUVs. We cannot move the car down here, because that car is a SUV. And this is for sedans. So what is the height of this floor? Around 1.8 meter. So it is okay for most sedans. The differentiation height, where we distinguish SUV and sedans, is 1.55 meters. And now we are taking the lift again to a floor where the height is higher. Please slow down. And now we're going to the 6th floor. This lift is really going very fast. And now we have moved into the 6th floor. So when it is going near the floor where it is going to enter, the speed will slow down for the precision and connection. And now we can see a better view for the round car park. Let's see if this lift can take the SUV on the top floor and take it down here. Now we are designating it to be parked in the third spot. Can we move it to the fourth spot? Because I know that the lifting can go together with rotation. So we are doing the rotation and the lifting together, putting it into the sixth floor's fourth spot. Because there is a process of rotation. Because as I learned yesterday, it does not need to rotate after lifting. Now we're waiting to see if this car can be precisely parked in the fourth spot in sixth floor. It is very fast, and the car has already come down here. It is not even a minute. The lift has come downward. It was in the fifth spot. The rotation has already been finished, but because of the head of the car's direction, we moved it. Now it is still in the third spot. Probably my colleague didn't hear my orders. Because it was parked in the fifth spot, and after coming down here, it has already been redirected into the fourth spot. This is even a little bit magical when I see it, because it is steady after you giving an order. There are no held-ups. I think there are a lot of entrances and exits, around 8. 14. Actually, it's 14 of them. So how many are there for the D car parks? 2. For A, B, C car parks, we have 4. We have 4 entrances and exits, respectively. Would there be situations where cars would have to line up and wait? So, at the same time, we can only lift one car. So after scanning the QR code, car owners can just leave. And these 4 cars will be taken up there, and you do not need to worry about that. It will line up automatically inside the car park. But when you are taking your cars away, you may have to wait for a little while. As I learned before, this is a smart car park. What is the thing that can embody the smartness? For example, I parked the car in the 7th floor. The lift will find a spot in the 7th floor because the lift can stipulate its path to run the shortest course to take all the cars outside. You have programmed the system into doing this. We have engineered softwares to automatically analyze the paths, how to realize a fastest way to take all 3 cars away. And today for demonstration, we have using orders. For example, would the cars be spotted in the first and second floor for convenience and fast extraction? Yes. It would not go up to 6th floor, whereas the lower floors are empty. Maybe some audiences are just tuning in our channel. And now let's show you the lift. How does it lift? And how does it rotate? Let's demonstrate again. This lift needs to rotate and then connect with our spot. Now we're bringing you onto the platform again. Okay, let's slow down. As we introduced, there is a security measure in the process of operation. We can operate from down there and also here. This is prioritized, right? When I am operating on this manually, the control room does not validate anymore. This is a double safety measure. If the control room fails, you can also operate up here, because we need to do daily maintenance right here, and then our staff can work from right here. Now let the lift take us to the ground floor, and you can operate this from here, right? Yes. This is rather slow. And there is a siren going on to guarantee the safety, showing the staff that the lift is going downward. This is stipulated by our national standards. We need to remind people who are down there and below us that the lift is going down. So in this slow process, you can see all the floors, and you can see all these cars, which will be occupying these spaces. Now we are at the second floor, between first and second floor, actually. Now let's go up again to lift it while rotated. The rotation won't be too fast. We'd better squat. This is for a more direct observation. Let's go to the 10th floor. Maybe it'll be too dangerous if we go to the top floor. As you can see, now we are lifting, and now we are rotating while going upward. This is the path that cars will go. So for our safety, the rotation didn't last very long. So after all this introduction, I think all of you may have an understanding for this 3D car park. So getting inside of this parking building and understanding the principles is a better experience for audiences. What we saw before is only the process of the cars passed in parking, but we have also other considerations in security and other technologies that we have not seen. Maybe what we're seeing is very simple, but the principles lying behind this is very complicated. Like the prevention of two cars parking together, as we can see this red light here. This is one group of light electricity that you're seeing right now, which prevents two cars into parking into the same space. You can see from a camera, this red one, when there are objects inside the pass. When we're blocking it, it will show. It can detect any objects. So we can prevent from two cars parking in the same space. So when one car is parked right here, the light electricity will be blocked. And the lift can detect its existence. So after judging, if we can see the two light electricity connects and there are no blockage, the second step is to determine if the car park has cars or not. Okay, let's come over here and slow down. This side also have light electricity. Let's take a look. It is right here. There are lights under this place. This is one layer of protection. Another one is the software in the control room. There are two softwares actually to record the existence of the car parks. How does it connect to the control room? Through this light electricity? We have 0 and 1s to indicate whether the car park is occupied. So by all these light electricities, we can determine if the spot is taken or not. So we can also detect if there is any object inside this platform. So when cars are going halfway onto the park, it will block this light facility as well. As you said, these all seem very simple, but the principles lying behind are more complicated. This is controlled by software and electricity. How does the reception and information be transmitted to the control room? Do we have a sensing facility? We have cables. To to transmit the reception and information into the control room. This is the signal for light electricity. After unveiling the secrets, what we're seeing is very simple, but what we can't see is very intelligent and complex. But the very core is all these electricity and technology. The machine and electricity help each other. That is to say, the software is also calculated by the computer. So the results of the car parking can be calculated by the software. So these sensing facilities serve as eyes and nose, and the control room serves as a brain. The software is actually the brain. And these are just eyes, nose, and ears. So by the collaboration of our brain and the eyes, nose, and ears can help the car park to do its full function. And now we will go down to the first floor. And now we'll show you the process of the lift again. And what's more, I want to talk about with our audience. A car park building like this, we have special facility and equipment, and we have reconstructed this. But there are a lot of buildings where conditions like this do not exist. How can we make it better? For example, we have a very advanced car park building, but we have also remodeled some old garages from 1 story into 2, 3, or 4 stories. I think this is a very good point by remodeling old garages. We have another approach as well. On the basis of the old car park buildings, we have added one equipment. We put in a special facility to help the cars park in a 30-degree. For example, the car park used to hold 24 cars, and now it can hold 40. And we have a video clip in Nan'an district in Chongqing city. That is also a very space-saving approach. And now we'll take this video clip to see this car spaces will ease the problem of parking.
量的要求，就是现有在原有24个位的这个占地面积上面的时候，我们就把它改到了40个。那这个呢，就把它的停车的数量呢，就提高到65%。司乘人员不用担心他的这个车辆会产生任何的这个因倾斜导致对车体的破坏，或者是车厢后边的这个货物的损坏。这一部分我们都用可能的数据支持。
We do not need to worry about about any damages.
好的，各位网友，刚才大家也是看完这个片子，是不是觉得非常神奇哈？就是这个倾斜
Okay, dear audiences, as you have watched this video clip, do you feel very magical? The 30-degree angle can be used for car parking, and it's very stable. So no matter what way do we use, this also shows the intelligence of the designers. For cities like Chongqing, a mountainous city, there will be more approaches for the convenience of our citizens. I want to show a very sincere gratitude for Mr. Cheng Qian, a technician who introduced to us the specific situation of this car park building in full details. And thank you very much. I hope that our audiences can pay more attention to the domestic designing of 3D car park. This is very practical and amazing as well. We hope this as well. There are adding numbers of convenience for commuting. So our live streaming concludes right now.